Okay, so we are doing number 52 on page 559. And the problem says a small metal sphere with a charge of 1.2 times 10 to the negative fifth coulombs is touched to an identical neutral sphere and then is placed 0.15 meters from the second sphere. What is the electric force between the two spheres? So we have our given, which is the distance is 0.15 meters away, and since the first charge hit the second charge, they're just going to split in half because the second one was neutral. So we would have Q1 equals 0.6 times 10 to the negative fifth coulombs, and Q2 will equal the same thing. And here we have Coulomb's constant, which is 9 times 10 to the ninth, and we are looking for the electric force. So the formula we'll be using is F equals K Q1 Q2 all over D squared. And then our work, we are going to plug everything in. So we have F equals 9 times 10 to the ninth times 0.6 times 10 to the negative fifth, and then 0.6 times 10 to the negative fifth. And then we're going to divide that all by 0.15 squared. And when we work that out, we get the electric force to be 14.4 newtons.
Okay, so we are doing problem number 4 on page 565. The problem says a pith ball weighing 2.1 times 10 to the negative third newtons is placed in a downward electric field of 6.5 times 10 to the fourth Newton coulombs. What charge with the magnitude and sign must be placed on the pith ball so that the electric force acting on it will suspend it against the force of gravity? Okay, so we have the weight, the force of gravity, which is 2.1 times 10 to the negative third newtons. We're trying to find the charge, and then we have the electric field, which equals 6.5 times 10 to the fourth Newton coulombs. The formula we're using is electric field equals force over charge. So our work is, we're going to use, we are going to do set 6.5 times 10 to the fourth Newton over coulombs, set it equal to 2.1 times 10 to the negative third newtons over the charge. And now we're going to solve for charge, and the answer we get is 3.2 times 10 to the negative eighth coulombs equals the charge. And for the sign, we have, so the force of gravity plus the electric force has to be equal to 0. So if you do the electric force and you move the force of gravity to the other side, it will be negative. So, because the electric force over coulombs, which is electric field, is positive, the force of gravity has to be negative. So we're going to make this negative in the problem, and our answer will be negative.